Coming to the third section, external fixators. What is meant by external fixator? Comparing with the internal fixators, where the plate or nail will be lying within the body of the patient. Here in external fixator, the maximum components will be lying outside the body surface, and only few components like pins and the K wires that will be lying inside the patient's bone, or they will be lying internally. Yes. So when we will be applying an external fixator for compound fractures or open fractures. Yes. So because whenever in an open fracture, we know that there is a wound at the fracture site. So when we apply a plate or nail, there is a chance that there might be a infection or osteomyelitis in near future. So it will be better to apply an external fixators. Then even when there is no compound wound, if the patient condition is not fit for a major surgery, that time we can do a temporary fixation with the help of the external fixators. Then we can postpone the surgery after 4 to 6 weeks once the patient condition improves. So for temporary fixation of fractures, even when there is a closed fracture, we can go for an external fixator. Then for a intra-articular fractures, whenever there is a more comminuted fracture at the articular surface, then we can go for a joint spanning external fixators. What is the purpose of external fixator? They are applied to maintain the length, alignment, the bone fracture alignment, then rotation. The rotation also more important. Yes, so for the rotation of fracture. So there are two types of external fixators. One means pin fixators. The second one is a ring fixators. Yes, in the pin fixators, they use a specific pin called as SCHANZ pins. So this is a SCHANZ pin. So this first three are made up of stainless steel, and this one, the colored one, is made up of titanium. As you can see in the tip of the SCHANZ pin, there are multiple threads, and there is difference in the length of the thread. Yes, this is 32 mm threaded, this is 48 mm threaded, this is 16 millimeter threaded. So which means based on the thickness of the bone or the part of the bone, assume that the metaphysis is one of the thickest area. So in the metaphysis or the cancellous area, we will apply a 48 millimeter thread. Then for the minimally thick area like the diaphyseal area, we prefer a minimal threaded SCHANZ pins. Yes, and one more thing, there will be difference in the thickness. Generally, I prefer to put 4.5 and 5 mm in tibia. Yes, for tibia fixation, or 5 to 6 millimeter thick SCHANZ pin in case of a femur external fixation. Then regarding the components, this one is called as a external fixator rod. Okay, universal external fixator rod, and this component is called as A-scallop, A-E-S-C-U-L-A-P, A-scallop clamp. So there are of two types. Thus the one with a small bigger hole is called as a rod hole, and this one is called as a pin hole. So this one is called as pin to rod clamp, and the one with the both the rod holes are called as rod to rod clamp. So here, as you can see, the SCHANZ pin is inserted into the cortex of the tibia. Then the SCHANZ pin is connected to the rod with the help of the A-scallop clamp. So here we have maintained the length, rotation. Minimally it is in the varus. Yes, length, rotation and alignment is more important. Okay, now coming to the second type of the pin fixators, they are called as rail fixators, also called as limb reconstruction system. So here we use a specific type of SCHANZ pin called as a tapered SCHANZ pin, which means the thickness will be tapering from top to bottom. Okay, so that's why it's called as a tapering SCHANZ pin. So what are the components? This is called as a rail. Yes, and this one is the mobile clamp, and this one is a fixed clamp. So the mobile clamp will be movable in the rail, and the fixed clamp will be fixed to the rail. Yes, and this is a T-shaped clamp for the articular surface or the condylar surface. So what is the use of the rail fixator? What is the advantage of a rail fixator on comparison with a normal external fixator? In the rail fixator, we can be applying it as a definitive fixation because they can hold more tensile strength or they can hold more stress than a normal external fixator. because they are having a tapering and a thick SCHANZ pin. Yes, and one more thing, they due to the mobile clamp, they can also be used for the limb reconstruction or limb lengthening process similar to Illizarov fixators. So coming to the second system, Illizarov ring fixator. So this is the component, these are the half rings that will be combined to form a full ring. Regarding the Illizarov indication, principle, everything I have explained already in the management of fracture chapter. Yes, you can go through it for the further explanation. Now I will be mentioning about the components. Here in Illizarov, we will be applying or we will be fixing the ring to the bone surface with the help of the long K wires. Yes, so in the long K wires there are of two types, the simple thin K wire and one more thing is called as a K wire with the olive. So the normal K wire will be like this and the olive K wire will be having a bead. So this bead will be lying outside the bone surface and that they are used for alignment or compression at the, they will be having a better hold to align the deformity at the fracture site. So these are the components. So this is called as a female post, this is called as male post, this is called as a connection plate or a connecting plate, and this one is called as a rancho. So this is a single hold rancho and this is a two hold rancho. Through the rancho we will be fixing sometimes for extra stability or extra hold at the fracture site or extra hold at the bone surface. We will be putting the SCHANZ pins. For the fixation of the SCHANZ pins we will require this rancho, R-A-N-C-H-O. Yes, then this is the SA node, which means without this we cannot fix the Illizarov frame. Okay, so this is called as bolt and this one is called as nut. So this thing you should remember, this is nut and this one is called as bolt. Okay, and this one is called as a wire fixation bolt. Wire fixation bolt. So these are the components of Illizarov. Then coming to the routinely used implants. Yes, so the first thing will be the K wire, also called as Kirschner wire. Okay, yes, so this without K wire you cannot do any surgery in orthopedics. Yes, any surgery is not possible without a K wire, because maximum surgeries, either it is an internal fixation or an external fixation, we need K wires. Even though if we are not fixing the bone with the K wire, they are used intraoperatively either for drilling the screw hole or either for a temporary fixation of the any fractures intraoperatively. We require K wire irrespective of the mode of treatment. So the K wires are the part and parcel of any surgery in orthopedics. You should know everything about K wire. They are available from 1 millimeter through 3 millimeters also, or even more than that. Yes, they will be having a sharp pointed tip on the both the ends. Okay, so this is also important. They are of different length also. If it is a very long K wire, that is usually used for Illizarov fixation. Yes, if it is a comparatively around 15 to 20 centimeter, they can be used for the fibular shaft fractures. They can be used even for the radial fracture, radial shaft fracture, ulnar shaft fracture. So K wire has n number of uses for the articular fractures or extra articular fractures like a supracondylar fractures in children. We routinely fix it with the K wires. Yes, so the K wires are the part and parcel of the orthopedic surgery. Yes, now coming to the screws. Okay, so this one is called as a cortical screw. Why it is called as cortical screw? Because it is applied to the bone cortex or the diaphyseal cortex. The cortical screw can be either applied through the plate, yes, or they can be applied even with not going through the plate. They cannot be applied to the bone directly also. So there is a different name for that. That principle is called as a lat screw or interfragmentary screws. So what is the difference between a cortical screw and the one more variety, cancellous screw? See here in cortical screw, the thread is very small. Okay, the thread height is very small and the difference between the next thread is also very minimal. As you can see, they are very tightly packed in the cortical screw. The the threads are tightly packed. They are closely packed in the cortical screw. On the other hand, in the cancellous screw, the threads are somewhat loosely spaced out. Yes. Then coming to the purpose, this is called as a lax screw principle or interfragmentary screws. So whenever there is a short oblique fracture or a long oblique fracture, yes, so instead of applying a plate, sometimes we can apply a screw. This cortical screw can be applied in an oblique manner perpendicular to the fracture site. So this point is more important, because whenever the cortical screw is applied perpendicular only, then only it can provide the required compression at the fracture site. So this, after applying this screw, before applying this screw, we need to do one thing. So what we will do, before applying the screw, I will be drilling the area of the bone. While drilling, I will be drilling very minimal, or I will be drilling around the required area. Assume that if I am going to apply a 3.5 millimeter screw, I will be preferably using a 2.7 millimeter drill bit. So I will be drilling a 2.7 millimeter hole in the opposite cortex or the far cortex. On the other hand, I will be over drilling the proximal cortex. Yes, I will be over drilling the near cortex. So what will happen, once this screw passes through this hole, they will be providing compression at the fracture site. So this type of fixation is called as lax screw fixation or interfragmentary screw fixation. Yes, so I have already mentioned in plate fixation, whenever we apply a plate to support the lax screw, that is called as neutralization plate. So the neutralization, before application of the neutralization or protection plate, we need to apply a lax screw with a proper hold to compress the fracture site. Then coming to the cancellous cannulated screw. So here in the cancellous screw, as you can see, the pitch, which means the thread height, it is called as pitch or vertex. Okay, so the larger the thread and the pitch is very high in case of the cancellous screw. And one more thing, why I have mentioned as a cancellous cannulated screw, see, you have seen the guide wire passing through the center, which means there is a hole, which means there is a hollow structure within the screw. It is called as a cannulated cancellous screw, or routinely we used to say it as a CC screw. So this is a CC screw. So why the CC screws are used? They are generally used for, they can also be used through the plate or without the plate also. So for the, whenever you are fixing the fracture at the articular surface, then you have to apply a screw through the cancellous part of the bone, which means the articular, the subchondral bone. Then we have to apply a cancellous screw, because that will have a good hold at the cancellous bone surface. Yes, then if I want to use a cancellous screw separately, then I will be using a partially threaded cancellous screw. What is meant by a partially threaded cancellous screw? As you can see here, the threads are present only in the distal aspect, not at the proximal aspect. So this is called as a partially threaded cancellous screw. On the other hand, this is a fully threaded cancellous screw. Yes. So what is the purpose of this partially threaded cancellous screw? Assume that this is the fracture of the lateral condyle of the tibia. Yes. And there is some displacement at the fracture site. So I want a compression at the fracture site. So what I will do? I will insert a guide wire here first. Then I will insert a partially threaded cannulated cancellous screw. So what will happen, once this partially thread passes the distal fragment or the second fragment, this will provide, because this will have a good hold at the cancellous bone surface. So after passing here, once I tighten the screw, this will provide the compression, or this will reduce the displacement at the fracture site. Okay. Then coming to the third screw, it is called as a HERBART'S screw. So what is the difference between the HERBART'S screw and the normal cancellous screw? It is also having a widely pitched, or they are also having thick threads at the distal surface. So in HERBART'S screw, there are threads both at the proximal as well as the distal aspect. And one more thing, they are called as headless screw. Yes, as there is no head here. So this part also will be lying within the bone surface. Yes, so whenever there is a intra-articular fracture, assume that the patient is having a lateral condyle humerus fracture or a lateral epicondyle fracture of the humerus. So I cannot fix a plate because the chunk will be very small. Okay, yes, so this is a lateral condyle. This part only is fractured. Yes, so I need to put a something to fix this fragment. Yes, so I want to fix that fragment. So that is the first purpose. And the second thing, this being in the articular surface. Yes, assume that the fracture is coming in the articular surface. So I don't want any part of the screw to be protruding out into the articular surface. So what I will do, I will put a HERBART'S screw and bury the head part or the proximal part. As I told you, there is no head for this screw. Even this proximal thread will be lying within the bone. Yes, so these are also called as headless screws. Yes, and for the small fractures like a carpal bone fracture, scaphoid fracture, lunate fracture, so these screws are available in small lengths also, so they can be used for the small bone fractures. And one more thing, you will be having a doubt, sir, we need to remove the screws after some time. So whether we should, how is it possible if we need to remove, if we bury it very deep? So these screws are made up of titanium, so you need not plan for any removal. So and they are even magnetically inert. So with this screw, a patient can go and take the MRI also if required, since they are magnetically inert, made up of titanium.